Hello, class. We are going to move on from covalent bonds to ionic bonds and ionic compounds today. It is a completely different type of bonding. We started with covalent bonds, that is sharing electrons, and now we're moving on to ionic bonds, which is actually giving electrons to another atom. So you have the transfer of electrons. So we're going to compare and contrast chemical formula, the difference between a molecular formula and an ionic formula. So two very different things. We're going to discuss the arrangement of ions in crystals, very structured. We're going to define lattice energy and explain why it's important. And we're going to list and compare the distinctive properties of ionic and molecular compounds. And we're going to go back to writing Lewis structures, but not just of neutral compounds, now of compounds that are, well, not compounds, but now of polyatomic ions. So very different. All right, an ionic compound is defined as it is a compound composed of positive and negative ions that are combined so that the number of positive and negative charges are equal. You see the image here. Here is sodium chloride, table salt. It is crystals. What happens with table salt? You have sodium, which has one valence electron. You have chlorine, which has 7. So sodium really wants to get rid of an electron. Chlorine really wants an electron. So sodium is more than happy to give its electron to chlorine. Now what happens is you have a sodium ion, chlorine ion. They are positive, negative. They are attracted together. And what happens is it just repeats over and over and over again. Sodium chloride over and over and over again. It creates a three-dimensional network of positive and negative ions mutually attracted to one another. Now, the chemical formula actually becomes NaCl. It's simply written as that. It's just one sodium for every one chlorine. It's a 1-to-1 ratio of sodium ions to chlorine ions. You can see the difference between covalent bonding and ionic bonding. And then covalent bond that we talked about in the last section, you have just the sharing of electrons between two atoms, and it forms a bond. In an ionic bond, with the transfer of electrons from one atom to the other, you get positive and negative charges, and it creates this big lattice of repeated positive and negative charges. All right, so what is the formula for an ionic compound? It's called a formula unit. It's the simplest collection of atoms from which an ionic compound's formula can be established. So here you have potassium and chlorine. Potassium is a +1 ion, chlorine is a -1. So it is a 1-to-1 ratio, so its formula unit would be KCl. Whereas calcium fluoride, it is a +2, where fluorine is a -1. In this case, you're going to get 2 fluorines for every 1 calcium, so it's CaF2. All right, so when writing the Lewis structures for ionic compounds, it's a little bit different. You have your electron dot notation. Sodium has 1 electron around it. Chlorine has 7, and it's got 7 valence electrons. Sodium wants to get rid of its electron, give it to chlorine, and you can see here what happens when sodium loses its electron, becomes a +1 charge. Chlorine gains an electron, becomes a -1 charge. Both are happy now, both have 8 electrons that are outer shells. Now calcium, on the other hand, has 2 valence electrons. When it combines with fluorine, fluorine only wants 1, so if 1 electron goes to the fluorine's happy, but the calcium still needs to get rid of another electron, so it requires 2 fluorine atoms to be there. So calcium becomes a +2 anion or cation because it's lost 2 electrons, where fluorine becomes a fluoride ion where it gains 1 electron. So it becomes CaF2. All right, crystals of ionic characteristics of ionic bonding. They form an ionic crystal. So it's called a crystal lattice. It has minimum potential energy. Crystal lattices in nature are minimum potential energy. They're orderly arrangement. When a crystal lattice is formed, it releases energy. That's called the lattice energy. Usually it comes from two pretty unstable things forming something very stable. releasing usually a large amount of energy. All right, comparing ionic to molecular compounds, very different mostly based off of their attractive forces. Ionic compounds, full on positive, full on negative, very strong attractive force. That attractive force makes it have very high melting and boiling points, makes it hard and brittle because it doesn't have a lot of give to it. Since there is no movement of ions in the solid form, they are not conductors of electricity. But when they are in their molten or dissolved, ions will move, allowing it to conduct electricity. Molecular compounds, on the other hand, have weaker attractive forces. They're not as strong. They have low melting points and boiling points because of this. Also, they are not electrical conductors because there's no ions present. Some examples of melting and boiling points. You can see the ionic melting and boiling points much higher. Once you get down to the covalent, much lower. Polyatomic ions, they are a charged group of covalently bonded atoms. And drawing the Lewis structure for it, you can see ammonium. It has 8 valence electrons around it. It's going to have a +1 charge. Nitrate, it's going to have the double bond here, -1 charge. But the big thing is the electrons available compared to the electrons actually used. You are going to want a difference here. Ammonium is going to have 1 extra proton. All of these are going to have extra electrons. Phosphate being one that has 3 extra electrons.